Hello, this is Randy. Today we're going to look at a whole variety of types of functions. For example, right now you're looking at two different sine curves. We'll also look at quadratic functions, cubic functions, square root functions, and others, all with the goal of trying to figure out what type of transformation did we apply to the green curve in order to get the blue curve. Here we go. So, although you don't need to know the name of each of these types of functions in order to answer the questions, I decided to tell you just as my little gift of knowledge to you. So, this first type of curve that we're looking at is a quadratic. The next one that we'll look at is an absolute value function. After that, we'll look at a square root function. Then we'll look at a cube root function. Then we'll look at a trigonometric function. In this case, we have a sine curve. And lastly, we'll look at a cubic function. All right, now that you know the name of all those different types of functions, let's look at the question. Identify the type of transformation demonstrated as the function below is transformed from the green curve, f of x, to the blue curve, g of x. And all of the four options in this topic are transformations that you've seen before. So we have to choose between shift, reflection, vertical scaling, and horizontal scaling. So let's see what we can eliminate. I know that with a horizontal scaling and a vertical scaling, the shape of the graph will change because it will be compressed or stretched. But I can see that this green curve and this blue curve are the exact same shape, so we know that the answer could not be C or D. Now, is this green curve being reflected over the y-axis? It's not, because if it were, the vertex of the blue curve would have to be at the exact same y value as the green curve, but it's not. So we know that this transformation is not a reflection either, which leaves only one option. It must be a shift. So although it's not part of the question, I'll just say that this graph was shifted 2 units to the left and 1 unit up. So A, shift, is clearly the only possible answer. Let's look at this next one here. The question is the same for each of these, so we're not going to read it over again. So we need to figure out, going from this green graph to the blue graph, what type of transformation happened? So we know that the shape of the graph will not change if it's a shift. So the answer could not be A, and this graph is clearly not being reflected over the x or y axes, so B is not the answer. Now, is this a vertical or horizontal scaling? Okay, let's think about a vertical scaling really quick. If the blue graph were a vertical scaling of the green graph, then every y value would either be shifted up or down as we multiply it by k, right? But we can see that this vertex right here at 0, 1 did not move up or down. So this could not be a vertical scaling. Now let me show you why it's okay that the vertex did not move when we have a horizontal scaling. It's because this vertex is at the x value 0, right? So if you remember from the video where we talked about horizontal scaling, when we have an x value of 0, and we're doing horizontal scaling, that is the one point that will not move when we transform the graph. So in this case, going from the green graph to the blue graph, we have a horizontal stretch. So D is the answer, horizontal scaling. All right, let's see what we have next here. All right, now, did we shift, reflect, or scale to go from this green curve to the blue curve? All right, let's think about shift. This graph that is green goes up to the right, and this graph that is blue goes up to the left. So these are not the same shape, which means that this cannot be a shift. They're going in opposite directions. All right, so A is not the answer. This looks like a reflection over the y-axis, but let's make sure it's not C or D. So I think the easiest way to eliminate C and D is to ask the question, is this green graph being compressed or stretched vertically or horizontally in order to get this blue graph? It's not. There is no compression or stretching happening. So C cannot be the answer and D cannot be the answer. And we can clearly see that the green graph is being reflected over the y-axis in order to get the blue graph. So our answer is B, reflection. All right, let's see what's next here. We now have a cube root graph, and let's try to eliminate whatever we can. So it looks to me like every point on the green graph is being moved up and to the right in order to give us the blue curve. But let's make sure that we can eliminate B, C, and D before we choose A. All right, is there a reflection over the X or Y axes happening? Definitely not, so B is not the answer. And is the green curve compressed or stretched to give us the blue curve? Definitely not, because the green curve and the blue curve are the exact same shape. So C and D cannot be the answer, which means that this is a shift to the right and up. How many units to the right and up? So although you don't need to say this as part of your answer, looks like we went 2 units to the right and 3 units up to get the blue curve. All right, what do we have next here? All right, the trigonometric function. In this case, it's a sine curve. So hopefully you are immediately seeing that in order to get the blue curve, we stretched this green curve vertically. So this should be a vertical scaling, but let's eliminate the other options as usual. So both graphs should be the same shape if we have a shift, but we can see that the blue curve is definitely taller than the green curve, so they're not the same shape. So we can eliminate A. And are we reflecting over the x-axis or the y-axis? Well, it's pretty easy to see that we're not, because, for example, this part of the green graph and this part of the blue graph are both in the first quadrant, so there's no reflection happening. So let's eliminate B. And let's think about D real quick. Could this be a horizontal scaling? Well, I see that we have one point at 0, 0 and another point at 3, 0, and both of those points are on both curves. So there was no horizontal stretching or compressing happening. So goodbye option D. And that leaves us with option C. This was definitely a vertical scaling because the blue curve is a vertical stretch of the green curve. Okay, hopefully you've been pausing before I do each of these. If not, make sure to pause it now before the last one. So let's see what this last question is. Obviously it's the same question, but we just have a different graph to examine. So immediately I see that these are the same shape, so I'm thinking the answer is going to be A, but let's eliminate B, C, and D real quick. So let's think about C and D. We know that if the answer were C or D, the graphs would not be the same shape because they would either be stretched or compressed. So let's eliminate C and D because these are definitely the same shape. Now, could this be a reflection? Well, if this were a reflection over the y-axis, all of a sudden this part of the green curve would show up over here, but that did not happen. And if this were a reflection over the x-axis, this part of the green curve would show up right down here, but that definitely did not happen. So this could not be a reflection. So goodbye option B, which leaves us with a shift. This is an example of a shift. In this case, it was 2 units to the right and 1 unit down. All right, and remember, you can always look back at the last several videos in this unit in order to review each of these types of transformations. And that is everything for today. See you next time.